Assalamualaikum and greetings to all panel that present today. My name is Muhammad Alif Firdaus by Muhammad Sabri, and right now I'm going to present my final title, which is Identification of Natural Compound from Filaria macrocarpa and its potential usage in modern medicine. This title is collaborated with UTM MJIT and Delight Flex Ltd. So, have you ever heard about Filaria macrocarpa before? Well, it's a plant from Tamiliaceae family that originated from Papua Island. It has been used traditionally for treatment of cancer in Indonesia and also to cure many diseases like liver diseases, heart diseases, diabetic, skin diseases, and many more. In traditional Chinese medicine, it is well known use for the herbal tea as well. Valeria macrocarpa proved its value claims as an anti-cancer agent through various modern sophisticated techniques in modern pharmaceutical industry. So, what are the problems that come out from these studies? So, what is a potential phytoconstituents in Valeria macrocarpa that are benefits for the future medicines? Since the Valeria macrocarpa is one of the traditional plant, it has been commercialized in the pharmaceutical industry indirect, which is currently used only in traditional medicine practice. As we know, for the plant extracts, the conventional extraction are commonly used nowadays, but it has some lack of practicality and disadvantages, which is difficult to remove room temperature solvent extraction, residual solvent completely, and possibility of thermal degradation due to high temperature and longer the extraction period. So what are the objective for these studies? So the first one is to identify and quantify the extracted phytoconstituents from Valeria macrocarpa. And the second one is identify the most beneficial and best sources of phytoconstituents that isolated from various parts of Valeria macrocarpa. And the third one is we are going to optimize the extraction method using different solvent and conditions. So before we proceed with our extraction and phytochemical screening for these studies, we have to prepare our samples of Valeria macrocarpa. So in this experiment, we are going to utilize all the parts of the plant of Valeria macrocarpa, which is bark, fruit, whole plant, seeds, pericarp, and mesocarp. Plant was collected from ethno resource Sri Berhad, and we are going to use three different drying methods, which is air drying methods, which is at room temperature. Second one is tray drying at 40 degrees Celsius, and the third one is sun drying, which is dry up to a moisture content below 10% wet basis. And then sample will be coarsely powdered using a motorized grinder, and then the powder will be placed in dry, cool, and dark position in an airtight container until the study starts. So after we prepare our samples, so this is the chosen of the extraction methods of Valeria macrocarpa. As we can see that this they have some conventional methods and non-conventional methods together in this picture. So the first one is solvent extraction. The second one is accelerated solvent extraction. Third one is a microwave assisted extraction, and the next one is a decoction and diffusion. After we extract our Valeria macrocarpa by using the various kind of the methods, and we are going to undergo proceed with a phytochemical screening, which is identify of phytoconstituents of Valeria macrocarpa by using the HPLC and also for the GCMS gas chromatography mass spectrophotometry. So in this part, I will explain detail about the solvent extraction, types of method extraction, which is solvent extraction. That this is one of the conventional method that used in plant extracts. So the solvent used is various and such as ethanol, hexane, methanol, ethyl acetate, chloroform, butanol, and water. And then this is description that as you can see that the steps that description and steps that we are going to optimize by using this solvent extraction methods. So the next one is one of the non-conventional methods compared to the conventional methods in terms of time consuming and how the optimization of the condition for the methods ongoing. So this is accelerated solvent extractions. So the equipment is we're going to use accelerated solvent extractor, and this is the condition and parameters that we are going to optimize if we do these methods. And this is our description, shows the methodology on how we are going to do for the accelerated solvent extraction. The next one, another one of the non-conventional method, which is microwave assisted extractions. So this is the condition and parameters, as you can see that in table below this picture. And after MAE treatment, the extract will be filtered through a number 1 filter paper, line Bushnell funnel, and the supernatant will be collected in a volumetric flask. The extract will be stored at 4 degrees Celsius until further use. So the next one is the common widely spread use of the plant extraction methods, which is decoction and infusion. The decoction method is suitable for the water soluble and thermostable constituents. The powdered sample will be boiled in a specific volume of water, which is ratio 1 to 4 for a defined time. Volume is allowed to reduce to quarter of the original. It is then cooled and filtered. So it differs compared to the infusions. The fresh infusion are prepared by the macerating the samples for a short period of time with cold and boiling water. The infusion will be filtered and supernatant will be collected. So after we extract and do our phytochemical screenings, so based on our literature review and based on literature review that have been made, and also reflects with the objective of these studies to identify the most beneficial and best sources of phytoconstituents that isolated from various each part of the Filaria macrocappa. In this table, they have been summarized that each part of Filaria macrocappa that we expect to get a phytoconstituents which is respectively to the parts of Filaria macrocappa in this table. So another information that each of phytoconstituent have its own biological activity. As example, that parts of Filaria macrocappa, which is fruits and leaves, are rich in gallic acid, and the gallic acid have its own biological activity, which is anti-cancer activity. So the next one is reflect to our objective, which is optimization of extraction method using different solvent and conditions. So this is summarized table that we expected we want to should get the constituents if we use different kind of solvents. So this another information, another expected we are going to expect for our results, and for the phytochemical presence in the various types of drying methods, which is if you notice in the plant preparation, we use 3 types of drying methods, which is tray drying, air drying, and sun drying. So this is example of the bioactive compound that related to antioxidant activity. So which is phenolic, flavonoid, saponins, alkaloids, and tannin. So in this table shows a plus sign and negative signs. The plus signs indicate the presence of phytochemical constituents, and the negative signs it shows the absence of phytochemical constituents. So what we can conclude from these studies and research experiments, that Filaria macrocappa proof can be potential future clinical use. As example, I can say that gallic acid that extracted from the leaf of the Filaria macrocappa that benefit in anti-cancer activity studies. So this research also can be a turning point for trend in pharmaceutical industry and future innovation in medicine. As to support and strengthen the statement from the WHO, which is health organizations, it estimates that 80% of people in developing countries relies on the traditional medicine for their primary healthcare needs, and about 85% of traditional medicine involve the use of plant extracts as source of drugs. So this is my project timeline for my progress for FYP1 and expected progress for the FYP2 that for the next semester. I think that's all. Thank you for listening.